thank you, Lincoln, and thank you for NIA for inviting us here for this webinar today. Good morning, good afternoon, everyone that's dialed in. Delighted to have you join us today as we explore a topic that could be critical for the future of clean energy. We're particularly looking at the role of SMR, so small modular reactors, in achieving net zero. Just to introduce myself, I'm Benedict Kleber from a company called Urenco. We're international supplier of enrichment services for the civil nuclear industry. My particular focus at Urenco is looking at the next generation of nuclear. At Urenco, our mission has always been to enable carbon-free energy solutions, and as of today, there's a tremendous challenge as we must decarbonize many industrial processes that require continuous heat and power. So as industries worldwide face increasing pressure to decarbonize, there remains a gap, as many processes today still rely on that high temperature heat and electricity. And that's particularly why we at Urenco commissioned the study. We wanted to provide an independent assessment of the potential market for SMRs in industrial applications, and to also further industry understanding of this evolving market. The report is also supported by WNA. So the study confirms what a lot of us has suspected. SMRs represent a significant opportunity. So with a strong focus on enabling delivery, SMRs can be maximized to their fullest and most competitive potential, and significantly enhance the ability of nuclear to make an important contribution to the energy security and net zero goals. To realize this opportunity, there's various different drivers that we've highlighted in the study. One of the key drivers was the way nuclear delivers projects. And in order to improve this part, there's a huge transformation that's needed. So we have looked at 4 different supply scenarios. We hope in commissioning this study that we can spark informed dialogue among policymakers, industry leaders, technical providers for SMRs, and ensure that SMRs are part of the conversation as we shape the future energy mix. So on that note, I'm happy to pass on to Mike Drury from Lucid Catalyst, who will unpack the findings of the report.
Okay, so hopefully my screen is now sharing. Lincoln, is that sharing? Can you see it properly?
That is sharing. That is sharing. Take it away, Mike.
So thanks for inviting us, and really good to kind of talk through this. Please, just as Lincoln said, if you've got any questions, do raise them in the Q&A. To be honest, good or bad questions are great, because it means you're listening, it means you're engaging, it means that we're actually doing something that's useful for you. So please do engage by joining in on the Q&A side of things. So let me just start with the opportunity itself and the need for energy. You know, there's a whole scenario that we're looking at of global growth, not just in nuclear, but in energy itself. Everything that we do, everything that we see needs more and more energy. And it's really important that we start to look at that global growth, but also the impact of that global growth, the industrial expansion that we start to see, and the need for things like what's going on in the Ukraine with energy security. And it's vital that we are ready for those kind of situations, transitions, and inflection points that we have. It's important that we have energy independence, and that we are still committing to those climate goals and changes that we were setting ourselves up to achieve. But that means that, you know, for nuclear industry, we've got a really good advantage. You know, it's low carbon, high density, reliable baseload power. And to be honest, it could be really useful for industrial expansion. However, and this is the kind of question that we have. In order to achieve that, we might need to address the user requirements for all those different industries. And today, most of nuclear has provided to baseload electricity. So it's important that if we are to meet that energy demand and energy security and achieving that net zero, we really do need to look at the market in a very different way. And that's essentially what we've done. I mean, we have looked at the industries and the different countries, and we were limited to North America and Europe, mainly because we just couldn't do everything in one go. So we took a proportion of the world and focused our attention on that. We looked at 11 industries again, and I'll explain why these 11 industries that we've chosen, but you can see that we've taken only 11 of those. So it's not every industry that we've looked at the moment. And we've looked at the supply and demand scenarios of, well, what happens if you're happy to pay for more expensive energy because you want energy security? Or what happens if actually, no, I just need low price of electricity because I need to compete with the other energy providers, and I'm an industry, I'm not going to move. And that starts to make you think about that market size. When you look at the different industries, you can kind of see that nuclear can be really competitive, and the penetration rate, you know, if you have $6 per MMBTU for the price of gas today, and you're competing, your market penetration rate is going to be quite low. But if you just increase it up to $10, you can start to see in a lot of those industries, we can start to really penetrate for nuclear. So it's important to understand that just because you've got nuclear and it's baseload power and we all love it because we're all in the nuclear industry, the reality is that the users, the people that are going to buy the energy, they actually just want energy at a low cost and a decent price, and they want security of it, they want reliability of it. So there's a lot of things that we have to really consider beyond just that price. And we started looking at that and analysing, what does that look like? You know, and here's just 8 of the criteria. There's a whole plethora of these that we've gone through, but you can see for the different industries that, you know, nuclear has some really good fit, but there's also some challenges along the way on there. And we have to really look at, well, how would we address that for nuclear to be able to access those markets? It's not quite so simple as let's just provide, you know, heat, or let's just provide electricity. We might need to work in conjunction with other industries, other suppliers to be able to support those industries as we move forward. So it's clear, though, when you do look at that and you look at final energy demand, you've got some big industries in there. You know, they're really, really using a lot of energy. But how are you going to get nuclear to support petroleum refining? It's quite a big ask. And people don't normally think, oh, yeah, nuclear, put that on oil and gas. Really? Well, actually, you'd be surprised. We talk to a lot of end users, and a lot of them are actually engaging with us to go, how can we deploy nuclear so that we can extract oil? We still need oil. We still need it for lots of different things. Actually, we could decarbonize our extraction processes by using nuclear. However, we have a real challenge of how to do it. So when we put all of those industries into a big kind of like, let's have a look, what's important, which ones should we focus on? Because we can't do every industry. We're only limited to 10. Urenco stretched us to 11, but let's not go down that route. When we looked at it, the reality was that actually 11 industries covered roughly 80% of the marketplace, which was kind of convenient, right? So we were going to do 10, 11 did 85%. Right, okay, let's do the 11. So this allowed us to kind of see where those high impact industries were, or where the industries that could be catalysts for starting stuff now and getting that first mover advantage in place. We looked at different scenarios of how you deploy it. So rather than just focus on what we do today in nuclear with a standard EPC approach, we looked at, well, okay, what happens if we build a fleet of reactors? What does that mean? What happens if we changed from building a fleet and commission projects where we're doing the same time and time again to actually having a rollout more akin to shipbuilding and maritime in the shipyards? What happened if we actually moved to like mass production. 360 reactors per year per factory. What happens if we can deploy much, much faster? If we change the approach from today's EPC type led reactor design, and you can see this happening in the marketplace, right? So it's not just me making this up. This is kind of standard. It's moving that way already. You're starting to see vendors really pushing towards those manufactured reactors, the design for manufacturing type approach, the approach that says, well, let's build it in the factory. Let's have it already pre-assembled. But what does that really mean? What kind of innovations are we going to need to introduce to that? Things like, well, if I'm going to build it in a factory, then I need to have it approved in the factory, ready to use. How do I do that? How do I set that process up? What do I do? What can we learn from other parts of the industry where we kind of do it already, like transport containers as an example, or type approval in the maritime industry? How do we get the regulatory assessments done faster and quicker? Those oil and gas companies, I said, when we got 8 of those together with the US NRC and the US DOE, 8 of them said, we'd happily go with nuclear. We've got plenty of money to fund it. However, I can't wait 10 years to put it on my platform to use to extract oil. I need it in 6 months and make a decision. Can we ever get to that? And that's where people are now starting to think, well, how do we do that? What kind of things can we do? How do we scale up to meet for a data center that wants 5 gigawatts, but actually needs to build bit by bit by bit and grow? Because it's not just about the cost of energy. That's one thing. Totally get that. You need to be able to compete with the competition. But actually, sometimes they have their own goals. They have net zero targets that they have to meet, or they just want security of supply. A data center that comes online. What was it? There was one in Holland, right, Lincoln? I'm pretty sure. Came online, had a secure for power purchase agreement in place from the grid, and then can't get it. So it's now diesel generating, trying to supply for that data center. So security of supply is really important, not just for countrywide energy security, but for the industrial users, because that's where they make their money, right? But the way in which you meet that, if we change the model from EPC all the way through to that mass manufacturing, we actually start to see that we open up markets. And we looked at 2 major regions, I'm going to call them. So the European continent, you can see it's quite a large area that we've covered there, and North America as well. So there's quite a bit that we've looked at, but it's definitely not everything. And when you look at those markets, you'll see there's some commonality in the top 5 industries, where chemicals, data centers, repowering coal-fired power stations, synthetic aviation fuel all fit into those top 5. And then depending where you are in the regions, you might have district energy. I say energy because sometimes it's cooling, not just heating. So it mixes into both of those. But you can see that the markets are pretty big. They're not small. $1 trillion market. And when you break it down and look at the way in which we've assessed that market, you kind of go, well, 700 gigawatt. Is that all? Yeah. 700, is that all? That sounds like a lot to me normally, but actually when you look at the global energy supply, 700 is quite small, and that is kind of limited because we've artificially put in how much we think the supply chain can deliver within the timeframes. That could massively change. So actually 700 gigawatt could be much, much, much bigger. But we had to limit it and be realistic about how many factories we thought would get built, how fast they'd actually be able to get into production, etc. And you can kind of see that that's a realistic figure of those industries and how much we could supply to them. But there is a huge need for transformation. And when you look at those markets, if you don't do transformation, you can't access some of those markets just because of simple little things like deployment time. Just isn't there. The size and scale of the units are too big for some of those opportunities to be able to access. So you have to have a product that's scalable and able to grow step by step by step, as in line with say the data center wants 5 gigawatts. We used that example earlier, right? 5 gigawatts, 100 megawatt per kind of unit of the data center. They want the power to come on incrementally. So how do you get nuclear to be able to provide for that? And I said earlier that, you know, you had these industries in different boxes of those that would be early movers and catalysts, but those that would actually have a huge impact on scaling up, you know, because the energy that's required for those industries is far, far greater. However, they won't make that commitment early doors. So you might see that you'll get those catalysts and early movers in very different industries to the high impact scale up industries. And that's not to say that industries are not taking things forward from each of those categories. And you can see here just an example kind of snapshot of some of those industries that are looking at nuclear right now, and the level of energy that's being kind of requested, if that's the right word, or kind of set up to provide for. You can see if we really wanted to move those things forward, then we're going to have to get from 7 gigawatt to 700 gigawatt, we're going to have to look at several different drivers. Delivery innovation, I've talked about, EPC to mass manufacture. Okay, great, that sounds good. Regulatory evolution, can we do it faster? Can we change the approach? How are we going to do that when you have multiple operators, multiple plants around multiple different industrial applications? How do you actually achieve that? And what is that regulatory pathway? And you're starting to see these things really moving forward, like in the US, and the way that they've kind of like, I'm not going to say ripped up the rule book, but they are really looking at that rule book. You know, even things like aircraft protection, you know, is being assessed and evaluated as to how it should be applied. But viability, or the economic viability, is crucially important. If you can't get that price, then you're not going to be able to supply to some of those industries, because unfortunately we are, you know, competing on price of energy, and that's really important still. So we must never forget that. And the way in which we deploy onto the sites, you know, it's good with the EN7 coming out, but effectively the approach that's being taken of, you know, can we go through a criteria and say, yes, this site meets that criteria, therefore we can move forward. You know, those kind of things are crucially important to be able to unlock and open new sites, new locations, which then allows you to secure capital and get access to it, because you're de-risking the regulatory pathways and reducing it. You're de-risking the construction by changing the way in which you do it. You're showing that it's economically viable, and there's multiple sites that you can move towards. And all that starts to pull into place, instead of having, you know, like a dispersed supply chain that switches on and off once every millennia type thing, you know, because we hardly build reactors, or we have a boom of construction and then we have a lull and then we have a boom again in a few years time type thing. Instead, you start to build ecosystems, and you have a mature supply chain, a bit like, I suppose, Toyota City in Japan, where you've got lots of the supply chain around Toyota and the factories, same as Jaguar Land Rover in the Midlands, and you see that supply chain really coming to the market to help grow that industry from 7 gigawatt to 700 gigawatt. What does that really look like? Well, effectively, that kind of takes us to key innovations that need to be done across those various different scenarios, across those various different drivers. And you can kind of see, we've just done a little list here to kind of help you to understand. Of course, there's a lot more detail behind what do you actually mean by full mainstream capital access? What do you actually mean by a high number for site availability? And of course, all of those things unlock that 700 gigawatt. So it's not as if you can't do one, or you move to the next, or you move to the next. You could do all of these in parallel. There's nothing wrong with that. It's just saying that if you can get all of those boxes ticked, then you can have access to a much larger and wider market. Lincoln, it looked like you were about to ask a question.
I'm just doing what I want everyone else to be doing and thinking of the questions I'm going to ask as soon as you're done, Mike.
Okay, cool, no problem. Just checking. So we looked at, I mentioned that we kind of worked with lots of end users. So we pulled together all of those end users and the requirements, and we started to look at what's the common things that are being put out by those end users. And it sounds really simple, doesn't it? They don't want to operate a nuclear power station. Okay, so how are we going to supply to that? How are we going to create reactors that don't need you to operate? They don't want to have any hazard or risk to operation associated, and how do they de-risk that? They don't want to really have to engage with stakeholder management because they're putting nuclear onto their data center or onto their chemical production plant. So how are you going to manage that? It's not purely about just providing the energy, and a lot of these end users, they buy the energy. They set up a power purchase agreement and they buy the energy. They don't have to worry about a nuclear project. So taking that away from them is an important part of assessing what the end users are looking for. And you can see, this is just a kind of level of product fit for the various different industries. This is not to say that one reactor is better than the other. What this is really to say is that there is a huge requirement to look at and really understand what your particular industry is trying to do, your particular company within the industry, what they're trying to do, and then marrying that or tying that or matching it, pairing it to the right kind of reactor that would support that industry. And that could be, actually, timeframes is really important. I need it now, I need it today. So you might say, well, I can't develop I'm going to say a very high temperature reactor because it's not on here, a very high temperature reactor because we haven't developed those yet. So that's what I want to do. Well, okay, that's not going to work if you want it in 2028. So there's real challenges that we have to kind of look at for these different reactors. And when you go through the kind of key things, the product requirements, you start to look at each industry and go, well, what's important to you? What do you really need? And then do these reactors support that part of the industry? And if they don't, then what do we need to do? Because many times we will look at our reactor, and having been a managing director for 2 reactor vendors, having helped set up Rolls-Royce SMR when we first kicked it off, and having assessed 13 or 14 different reactors and their technology and their R&D plans when I was at NNL, you start to really kind of think, well, actually the reactors are being designed to be a reactor. They're not being designed to meet the needs of an ammonia production plant or a data center application or a food and beverage industry. So when you look at those, you don't get the subtlety of what do you need the heat for, guys? How much energy do we need to recycle? What would be useful? What's the best approach? What temperature range do you need? So it's really easy to say, oh, this reactor works with this industry. It's like, well, not quite. It depends what you're trying to achieve and what does that end user need? And when you look at those 11 industries and really assess it and start to get into that weeds or detail or analysis, you start to see that there isn't one reactor that's perfect. There's lots of reactors. And the good thing about nuclear is we've developed lots of reactors already. So actually, there's a lot of underpinning information that exists. Don't get me wrong, there's a challenge. As always with nuclear, there's always a challenge, but there is definitely a market that you can access. And that market is pretty big. It's worth quite a lot of money. And it's something that really, we think, at both Urenco and at Lucid Catalyst, that we could access it. But we're going to have to make some changes to how we deploy, how we access, what we do, and what challenges we are looking to really understand with the end users that could provide that market. Lincoln, over to you for Q&A.
Sure, and I see people are taking our instruction that they're starting to come through on the Q&A. One question, a couple ones I will start off to give people some more time. We'll get to the questions in there. I want a couple of things, Mike. What does the industry need to do in terms of its design process to get down to what you talked about in terms of the transformation, basically mass manufacturing? Because I don't see it as just a challenge of how we make this stuff, but it's a different thing to design. You have to design factories, you have to design the logistics process, the way in which everything comes to site to get assembled. What do you see as one of the key things we need to do there to be able to drive down that cost curve and get the transformation, the mass manufacturing that we need?
Yeah, I definitely think that you have to move down for design for mass manufacture and assembly. If I go back to when I worked at Jaguar and building volume production cars, right? We had a modular construction, let's call it, but it was across 7 different vehicles. When I looked at my one unit, my transmission, it had to fit across 184 different derivatives of vehicle. So sometimes the application that we're making it for has to be understood and assessed very quickly at very early stages, because we couldn't make it perfect for everything, but we made it good enough for everything. So it ended up, I'll give you an example, a specific example. We had transmission casing had loads and loads of holes on it that still structurally strong enough to do its job, but the holes were I only needed 8 for rear face of block on my Jaguar, but Ford needed 12. Volvo needed 7. So the holes that are on there, we ended up having 12 to suit everybody, but not everyone needed it for their different derivatives. What you might find is we have to understand what industries we're really tailoring our reactor designs for, understanding that end user requirement first, and then going to the drawing board of, okay, now I need to think about, I'm actually going to make this in a factory. And as you say rightly, you need to start thinking about, well, how am I going to build this? How do I get just-in-time process in place? How do I get to the point where I've got sequenced build and logistics for supply chain to come in, deliver it, and allow me to assemble it? Because I can't just have hundreds of thousands of stock sat on the shelf. But equally, because we're going through this licensing approach and the way in which we do things today, how do we manage things like C&I obsolescence during builds and during volume production processes? What is the approach to how we regulate? Because I can't go back and change a safety case every 2 minutes because we've had to update a new sensor because they're no longer supplied. So the whole ecosystem that we look at will have to change, and the approach that we take will have to move more and more towards a manufacturing environment. And it might start with shipbuilding because it's lower volumes, lower kind of control, a bit more, let's say, flexibility. But as you move more and more towards that mass manufactured environment, then we'll really need to start to think about, okay, what's that factory end of line testing? What's the way in which we'll get regulatory approval on these systems? How do we ensure that we have poker yoke in our design, so that people can't make mistakes when they're manufacturing it? There's loads of things that we have to start to consider. It's not just about modularization and commonality of components. There's a whole plethora of things we have to start to consider.
One more question for me, and then we got a number that I want to get. Are you being too pessimistic about the cost saving we can get from a programmatic EPC approach? I noticed you had that in the 90 to 125 range. I think it's not in range of sort of, I think a Korean new build LCOE comes in considerably below there. The US plants currently are operating at just about $30. That's if with efficient builds, I know obviously that doesn't include the build and finance cost. With efficient builds and well-managed processes, if you say they can basically operate now for $30, can we not go below that $90 mark on a programmatic EPC?
I think it depends. It depends where. I think in the markets that we've looked at for North America and Europe, I think the values that we've put in align with the approaches that are being taken today and the reference data that you can kind of reliably point towards. That's not to say things can't be done better, but the way in which we get that cost drivers down, I think if you look at our previous report that we did on the nuclear cost drivers quite a few years back, you probably see some of those things that would really drive the cost.
It's one of my gospels, Mike, don't worry.
It would really drive the costs down. And yes, you're absolutely right. Like, you look in some of the other countries and the build programs that they have, the costs are moving down with programmatic approach, but the way in which they do their EPC is very different from how we do it in North America and Europe. That's not to say we couldn't learn from that, though. I definitely think we can. We could probably drive programmatic down a bit more.
Johanna said at an early question when we're working that is a lot of SMR and AMR designs out there in the market. I mean, dozens and dozens. How do we get a consolidation, or how many designs can we realistically support so that we can make the investment to get towards that transformation, that mass manufacturing mode?
Yeah, that's a really interesting question. We get asked this all the time. Which reactor should I go with? And customers kind of come back to us and say, I really want to look at all of these reactors that are operating in the US, or I'm really interested about these ones in Europe. And you go, that's a different list. And there's always a new person that's on the list. I think I would kind of look at, if you think of transformation, and you're starting to see this now, if you think of transformation a little bit like if you design the interfaces, the systems that it attaches to be common, to have common open architecture type approach, then you start to say, well, actually, if your reactor can supply and meet to that architecture, then you can access that market. So what you might start seeing, and you are seeing it, like Exxon set up a nuclear open architecture platform, where they're looking at developing standardized modules that fit to the reactor. So you can design whatever reactor you want as long as it meets the open architecture requirements and then outputs in the right interface features, etc., to marry up to their open architecture for the oil and gas industry. So I think the way in which we deploy will be very, very different. So actually, what's to say you couldn't have a DVD player with multiple different brands of DVD players, if that makes sense? So you've got DVDs, but multiple different brands of DVD players. You could do that, and they all know that they need to play a DVD. What's to say we couldn't move to that market? And how do we reach that goal, rather than saying, I've got a new plant, mine is specifically for that, specifically for that. You don't have that with 10,000 combined heat and power plants in the UK.
Yeah, absolutely. For those of you who are, I guess, Gen Zers, we'll put a little note for what a DVD is in the chat function later on. But I wanted to pick up a couple questions which are related, I think, from Aaron and from John. First one is, what is the those of you, if some of you haven't, I can see what you're putting in the chat function, so I can pick up those questions as well. What proportion of SMRs would you expect, SMRs, AMRs, say advanced nuclear, proportions do you expect to be fully factory fabricated? And do you see that as purely local supply chain, or we're still, like some other manufacturing industries, integrating a global supply chain into a just-in-time type mass manufacturing setting?
I mean, I know what we put into the market to kind of give us the output calculation of supply chain capacity. So we did limit the supply. But if I were just to paint a picture of what I see that future vision being, I think it's probably going to be regional supply. If you've got enough demand in an area, then you build a factory, because how are you going to supply to that area unless you have a factory local? And so you're not going to be building just one in the United Kingdom and shipping around the world. You're realistically going to be looking at how do you deploy for different regions, and have you got the regional supply chain in place to support not just that factory, but also the deployment onto sites. So I think you'd probably have regional factories, and you'd get clusters that then supply to those, with still very local supply chain to various aspects of those projects.
Sure. Questions related to that. On SMRs, there's a sacrifice of some of the economies of scale we've seen on the big reactors. A lot of that, some of that will be in operations. Do you think modularity mass production sets that off enough? And do you think it's mainly because it's concentrated on the construction? The modularity is about saving mass production, saving on the build cost, and it's the build cost rather than the OpEx, which is the main obstacle to the rollout at the moment.
I think build, I wouldn't say main obstacle, I'd say it's one obstacle. Build time and construction cost is definitely a challenge. You know, this just the pure scale of the cost is a huge amount for anyone to kind of have that balance sheet to be able to support. So I do think getting the scale of the cost down will be important as well. But also, you know, from an operational point of view, again, if I go back to the end users, you know, the end user is not going to turn around and have a data center that has a few people operating a data center. Oh, I need 500 for the nuclear reactor. You know, we're going to have to look at, well, how do we do remote operations? And it's not like we haven't had these kind of things in place in the past. You know, we have the ability to manage autonomous control over multiple things, and we've done it for years on various different activities, including reactors. And you know, we just don't really look at deployment in that way.
Yeah.
And if you said, well, actually, my reactor, let's take the Copenhagen Atomics one, 40-foot shipping container. You know, you're not going to have 500 people operating that one reactor, right? So we have to look at, well, how do you do that then? What is the approach? Do you have a centralized system? Do you have a workforce that moves around? Do you have emergency call outs? What's the approach? What are you going to do? And they're the kind of things that you need to address. So does it affect just the capital costs? No, I think it affects the capital costs for sure. Does it affect the operations? Yeah, I think it does too. You have to meet both. So there's a whole list. We had can't remember the exact number, but there was like a matrix of 16 by 16. So there's quite a few different things that you have to look at.
Yeah. One thing that you mentioned about shipyard manufacturing, question from Johannes is, what are the low-hanging fruits? What are the things to be the early adoptions to start getting into this mentality? What are some of the things we think we could adopt relatively swiftly from that shipyard approach?
Well, I think, you know, one of the key things when we built a nuclear module we were doing a testing kind of thing at NNL, you know, one of the challenges, and this was like a fuel assembly test piece of equipment, was actually the shipment from the shipbuilder to site and making sure that nothing had changed in between that process and the measurement that was needed to be able to see if there was any change and variation, so that we could really go from commissioned at the shipyard to operation at the site, at the plant. And that, putting on the measurements, the instrumentation, that was new, really. People didn't really do that in nuclear. You know, you'd commission here and then you'd commission, you do active commissioning there. I'm not saying we didn't do the active commissioning. What I'm saying is the bit in between, we did extra, loads extra on how do we manage that whole movement and that whole shipment, the methodology for transport. So there's loads of little things that we have to do like that. And I think there's huge opportunities to invest and get into, you know, various different parts of nuclear and thinking, well, actually, we already do this in maritime industry. How can I adopt that for nuclear? Because we already do it there.
Sure. One of the things that I guess this will be a question, Shagir's got a question, which I suspect a lot of people would ask looking at the industry from the outside. Why would end users choose SMRs when renewable sources might come with less risk and can start up faster?
I don't doubt that renewables can start up faster, and I think they're an important part of the energy mix. I don't disagree with that at all. However, some of those end users have already done that and struggled to get the power with the capacity factors that they need for their industrial applications. There's no guarantee that it's going to be windy or sunny, in which case they have to have things in place. So you're starting to see more and more people go, well, we made a huge investment in doing something and it hasn't paid off. We have to look at something else.
One of the things, another thing which you mentioned a couple of times about new regulatory approaches. Adam's got a question here. He said about where we need to be to support system licensing, and if there's a way also just thinking about it from my own, how you would reduce the need for constantly proving big safety margins on sites with minor variations in conditions that results in a lot of then bespoke engineering, which then pulls you further from the transformation, the mass manufacturing approach you've spoken about. What are the key changes you think need to happen there? And importantly, what can you think we can do as an industry to support that argument about what needs to change?
Well, do you know what? That's a really, really big question, Lincoln. And
we can speak for a couple hours on that, but you can have 2 minutes.
But you know, I'd love to answer that question with a colleague of mine, Zach, who has been doing loads of work on AI for licensing reform, how we need to modify what a transformation market would look like if we had the licensing in X, Y, and Z kind of ways. And I think the approach that we take to doing that, I suppose, is moving it more towards a class-based system, you know, like in maritime, just to simplify it a little bit, where you have a class type approval. We do it in nuclear as well, usually for transport waste containers, where they're type approval, and maritime is like a class approval, in which case the way in which we regulate will change too. It ends up, I suppose, in some respects being, well, can you demonstrate this very clear meeting of regulations, which may be a bit more prescriptive than we are as well at the moment. So there's lots of change that need to happen, but I'm quite happy for Adam to get in contact and can have a really deep conversation with Zach, because he's the licensing guy, if I'm honest.
There's a question that Grant had about how do you see about how reactors that have been developed independent of what they think that what the end users might actually need. Do you think there will be an evolution of that with more end user involvement in the development of the reactors, or do you think there's not the interest in getting involved in these things? How do you see that aspect of basically designing these things to meet somebody's need, to meet a customer need, rather than to meet a technical preference we might have as an industry?
Yeah, definitely. I mean, we're starting to see more and more industries really look at nuclear and go, could I get nuclear? Would that work for me? And then when they start asking those questions, they're like, well, what do I actually need? What's my driver as a customer? Because the way in which they've adopted the power in the past, they've just signed a power purchase agreement, really. But when you start to integrate them, and it's not like we haven't done this in nuclear, because we definitely have. You know, like I went to an aluminium smelting factory in France, which is right next door to an operating reactor that supplies the energy straight to the plant. You know, so we definitely
they did that at Wilbur too for many years.
Yeah, we do these things. Well, don't do it anymore, right? We do these things, and it's not like we haven't done them. I think my point is more that to access that large market, there'll be loads of those kind of conversations, and you'll probably find that you'll end up having reactors that are designed to support data centers as a whole. You know, reactors that are designed to support ammonia production because it kind of meets and fits the blend of what they're looking for. Or you might have intermediary things that are put in place, like, I don't know, thermal storage, so that they can then supply and meet the end user's requirements by feeding into that thermal store. The thermal store actually is providing what they need. So it's just a different way of setting up for some of those industrial users.
I got a question on the industrial use, and one of the things about data centers is maybe they want to expand, as you say, scale up gradually.
Yeah.
But also that data center demand can fluctuate, you know, within a day, or within, you know, it can peak and drop. And then maybe, you know, the data centers, they aren't being put up with a business case that lasts 30, 40, 50, 60 years, because they don't have that upfront capital intensity. Do you see a situation where you would have almost the ability to install or uninstall SMRs at a different site if you no longer need the energy, and reposition them, like that kind of mobility of a terrestrial reactor? Or do you say we just then stick excess on the grid and hope that means there's a competitive demand for grid electricity for other solutions to make that work?
I think you'll have that as a solution as well, but I think you'll have both. So you'll have some that stay on the grid and keep supplying, but I think you'll also have the ability with some of these reactors where they're treated, it's not the right terminology, but more like a battery. You put it in, you use it for 5 years, you then swap it out, get a new battery type thing. And you're starting to see like discussions with maritime industry where they don't want to operate the reactor, so they kind of put it in, have this unit, and then when they refuel, they just take the whole unit out and replace the whole unit. And you're starting to see that some of the approaches that vendors are taking is exactly that. And instead of, like throwing that reactor away, they take it to an offsite facility, refuel it there, and then deliver. The challenge then becomes, wait, hang on, how are we going to transport the fuel inside a reactor? Surely not. You go, well, okay, that's a very good question. We have to address that. And if you think about it, we do critical movements already. It's just in a transport container. So then you're saying, well, my reactor now has to be able to be drop tested and all sorts of things. So there's a whole myriad of questions that we still need to address on that.
On this one thing about industries, often they need 24-hour operations. And even with, data centers, they have the 5 nines, I think it is, reliability. Even if you have 2 or 3 or 4 or 5 reactors, there's still some chance maybe you can't supply the need. Can these industries accept, question from Daniel, can the industries accept a shutdown period to refuel reactors? Or do they need something like SMRs, which are designed to be refueled online?
Maybe designed to be fueled online, or maybe to put the redundancy in place. So when one is being refueled, there's others that are operating. But does the economics stack up to be able to do that? And that's the fundamental question you need to be asking. Can you make it so that your economics stack up for the entire business case and operations, not just for the capital expenditure?
Can I ask a different one? Maybe if we look, you looked at Europe, you looked at North America. We have the academic Lomonosov, which is the Russian floating nuclear. We have the Chinese SMRs. I'm not sure how modular they are. They're small, at least. And we have the BWRX 300. I think it's not yet at first nuclear concrete. And what is it? What capabilities do you see the Russians and Chinese have applied to get there, even though they're nowhere close to transformation mass manufacturing? What capabilities have they required to get these innovations over the line? What do we need to learn from them in terms of, I guess, the geostrategic capability? But then what mistakes have they made in pushing out these innovations that we could fix for our own application?
It's interesting. You say that's not the first time we've been asked about Russia and China, the applications. I think it's really, really enlightening that both Russia and China, China's got the thorium molten salt reactor, Russia's got Mozart molten salt reactor. And there's a plethora of reactors that have been under design and development at Japan as well. France is pushing and forging forward with lead cooled and bringing MOX back online. The US is supporting a whole variety of different reactor types for various different applications. And I see there's a race to develop the technology to support as many industries as possible. Before, back when we started the kind of industry, there was a need and a demand to kind of get the technology developed to support submarine program effectively, and developed reactors to support military applications and the generation of plume. Some of those reactors were all designed, well, all of our reactors are pretty much designed and built and operated and tested and brought to a certain level back in the 50s and 60s. But what you're starting to see now is that demand is not necessarily for military application. The demand driver now is about, can I secure energy at a lower cost? And that then starts to push you into different technologies for cost of energy. In which case, you're starting to see some of those older technologies coming back into, oh, we should look at this, we should develop this. And you're seeing other countries really pushing ahead with those tech.
Yeah. Could I challenge you? I guess challenge is the wrong word, Mike, but if you look at the Chinese have a number of technological innovations
Yeah.
in reactor tech, but the core of their nuclear program is a mass programmatic EPC build out of generation 3 plus
Yeah.
gigawatt scale light water. What should we learn from that? What should we take from that when we're looking at how we unlock this industrial market?
I think the approach in which they can build on a large scale EPC is very different from what we do in North America and Europe. The sheer number of people that they can put onto the projects is completely different. So the way in which you can deliver those projects, there's definitely learning on programmatic, and I'm not saying there isn't a cost drive from doing programmatic. That's why we have a whole scenario based on it. But I think we can move it even further forward. You don't hand build all those cars. You just don't do it. Even the Chinese don't do that, right? Yeah. And they've got hundreds of thousands and millions of people that could, but they don't. They build it in factories. There's a reason why things get built in factories. If you have consistent approach of what's needed, if you have consistent market and size that you can access, if you can actually start to kind of get your deployment in the timeframes that are needed for those end users. Nuclear's not been in that tradition. And for us, in most of our applications, it's been grid application. So actually, we can kind of weirdly support taking our time because we just haven't got the sheer number. They're going down programmatic because they're building up that number. But as you start to access industrial applications and the number increases, you'll have to do it a different way because you just won't be able to get them on time.
What do you think is, I mean, I suppose in some way, whichever method we do, we need to have the strong project management, program management capabilities. What capability in that sphere do you think that we most need to build up in the UK and Europe and North America to make this work?
I don't think we have the right kind of project management well understood for doing this approach. This requires us to move more to agile project management. I'm not saying that we don't have agile project managers. We definitely do. I just think there's more of that. And when you start delivering agile projects, what does that mean? How do you set up to follow that methodology as opposed to a waterfall methodology? So I think we start to then go, well, can we be comfortable with change within a program schedule and having design freezes that nothing changes, that then allows you to move forward? It's just a different way of doing things.
There's a couple of last questions. We have 4 minutes, so see if we can get both in. Are you thinking AMRs in the UK sense? Some people, I guess, call them all SMRs. Do you think AMRs can be targeting the same market as SMRs? Or for these applications, do you see them having a greater range or lesser range than, say, light water SMRs?
I think there is a different demands will require different technologies that could meet them. Some of the industrial users, an SMR just won't do what it needs, doesn't provide the temperature. The analysis that we've done, whilst it says SMR, is actually SMR and AMR. The reason why we've called it SMR is just because of global kind of understanding of the acronym meets. So it's Gen 3 and Gen 4 reactor types that we're talking about. And that's why the analysis shows the high temperature reactors, the lead cooled, sodium cooled, molten salt, and light water reactors. But the industrial users, what they need will kind of dictate what reactors are more preferable. It doesn't mean that they can't be supported by a light water or by a molten salt or a high temperature. It just means that there's attributes that may be a bit better strategically aligned to those.
Sure. And what do you see the role of micro reactors after 2050?
Well, I'm not so sure it's going to be. So I used to always think micro reactors, that stick it on middle of nowhere, and we can operate it. And actually, the price of the energy can be the same price as helicopter diesel, because nobody can get it there anyway, and that's what they have, and they pay a fortune for it. So fine, let's do what, $200 a megawatt or something ridiculous like that, and that's acceptable. It's weird because actually some of those prices are real. They really are that high. You think, geez, that's a lot. And why don't we build more over there? But I think actually what you start to do is, instead of it being a micro reactor for one unit placement, I think it would be more like reactors that can work in parallel with each other. And you're already seeing things like this. NuScale has its little modules that go in, 12 units go to create one power station. Copenhagen Atomics has 25 for a gigawatt power station. People are already starting to do units that then sequentially kind of come in and, like Lego bricks, build and scale to the size that they actually need. So will there be a micro unit that operates on its own? Yeah, but I think it will be able to fit like your AAA batteries that fit in your remote for your TV. You'll put two of them in. It's the same battery. Oh, hang on. I need AA batteries for, I don't know, the car for the kids at Christmas, the remote control car. I need 6 of those things. Actually, I need about 24 because they get used in 2 seconds. So I think you'll just have slightly different scales of technologies that can then go side by side to scale up.
Sure. Well, thank you very much, Mike and Benedict, before you for running us through all this. I apologize, there are a couple of questions we didn't get to. What I will say is, for those of you who want to see the slides, we'll drop Mike's email in, or you can get in touch with Stephanie on our membership team, and we'll get the slides sent through to you. If you want Mike's contact details, talk to Benedict as well. We can provide those as well, so you can follow up on what we've done today, because it's probably fair to say we've scratched the surface, maybe a little bit more, but there's quite a wealth of detail underpinning that report, and in all of these sectors, quite a growing energy demand, and room for nuclear then to expand as a solution there. Just on the nose, midday. So thank you all very much for your time. Hope you have a good rest of the day. I'm sure we'll see you around. Thank you for making the time. We'll catch you soon. Bye-bye.